In the last video, we created our core plugin and we also brought in inert, vision, and handlebars into the project. Now, sometimes when working with Happy's plugin architecture, you may run into a situation where a certain plugin depends upon the availability of other plugins to be able to do its job. In such a case, you need to ensure all dependencies are loaded in and available for a plugin to work. Fortunately, Happy is very well thought out, and you will not run into such a problem. Let me show you how. Here, in our project, for instance, the core plugin needs the inert and the vision plugin to be loaded and registered before it can do its job. To ensure this availability, we can simply go into the attributes section of the core plugin and create a key called dependencies, where we can pass in an array with the names of the plugins that we need for this plugin to work. So here, I'll pass in an array with two strings, inert and vision, and Happy will ensure that these two are loaded in before the core plugin is executed. Alright, next up, our main business logic for the app will reside in its own plugin, and I'm going to call it main. So within the core plugins folder, create another folder called main and place an index.js file in it. Begin as usual by scaffolding out the main plugin like so. By now, this process should seemingly be easy. If not, feel free to write in with your queries and/or watch the previous video where we created the core plugin. Now, a plugin is of no use unless it's registered, but this time we will register this plugin in the core plugin, and this should give you a sense of Happy's nested plugin architecture. Use the server.register method in your core plugin's index.js file right below the server.views method, and instead of passing in an array of plugins, we'll just pass in an object with the register property and use the require statement to load in the main plugin like so. Since our main plugin has to deal with the student data that we brought in via the options variable, we'll inject that in using the register function's options property like so. Also, create a callback function using the fat arrow function notation that takes in an error argument, and we'll just console.log this out should a problem occur in loading the main plugin. Do note that this callback function in the server.register method is mandatory. Now that we have created our main plugin, it's time we brought in socket.io. In this project, we'll use socket.io to relay the names of the students and file names of their corresponding ID cards as generated by the Python script in real time to our user interface. So begin by installing version 1.3.6 of the socket.io module like so. Now, since the socket.io module is used within the main plugin, it only makes sense to bring it in here. So use the const keyword again to create an identifier called socket.io and use the require statement to bring in the socket.io module. Now, inside the main function, create a constant called io, and we'll invoke socket.io like so and pass in the reference to our Happy server's listener, and this is all you need to do to bind socket.io to our server instance. Underneath the hood, Happy implements Node's standard HTTP server method, and the server.listener provides direct access to this server instance. Socket.io is thus able to directly hook into the individual server instance and is able to do its job. As you know by now, Socket.io's client library is also required in our view page, hence go in the index.html file and create a script source tag to point to /socket.io/socket.io.js. This route is instantiated and made available automatically by socket.io, and thus there is no need to manually create a route to serve this file. Next up, let's test to see if socket.io on the server is indeed able to connect to its client. For this purpose, I will first use io.on method to attach a standard connection event listener, which basically fires when socket.io on the server is able to connect to the client successfully. Once this happens, an instance of the socket is returned, which is like a discrete pipeline created per user through which we can communicate to and fro with the client on the page. So in the callback, for now, just do a console.log that throws the string connected once the connection is successfully established. Now, since we are running ES6 on the server, why not use it in the browser as well? The only problem though is that there is fragmented support as far as browsers are concerned. So the only way here is to use the Babel transpiler within the browser. Babel allows us to use ES6 in the browser today. However, in a high-performance production environment, this may not be the best approach since Babel transpiles down to ES5, and doing this every time will affect your client-side code's performance. The best approach in production for now is to pre-compile your scripts down to ES5 or just prefer writing your browser code in ES5 till such time ES6 is universally supported across all browsers. For this project, however, we'll just enjoy writing our code using ES6 and we'll let Babel do the needful. So first, let's get Babel for the browser. Using npm, download babel-core, and we're using version 5.8.22 in this project. Like all other modules downloaded through npm, Babel core also sits in the node_modules folder. The specific script that we need in the browser is called browser.min.js. But since this is in the node_modules folder, we'll first have to register a route with happy to serve this file. So in your routes array, add another route where, like before, the method would be get and the path would be set to /babel/browser.min.js. This is the path that we want to use in the index.html file. When this path is accessed, we will serve the browser.min.js file from the Babel core folder inside node_modules using Happy's file handler like so. Now simply go into the index.html file, create a script source tag, and use the route that we just registered to bring Babel into the browser. Let's quickly launch the app using NodeMon now. Before we can write ES6 in the index.html file, we need to set the type of our script tag here to text/Babel. This lets Babel compile down whatever is inside this tag into compatible ES5 code automatically. Now, since I'm using jQuery here, I'll begin by creating the jQuery ready function, only this time using an arrow function instead of the usual anonymous function. Next, I'll use the let keyword to define a variable called socket, and we're going to use this to invoke the io.connect method that socket.io uses to handshake with the socket.io at the server. This returns a reference to the socket, which we can then use for our communication. So we just used an ES6 keyword called let to declare our variable. Let's quickly see how it's different from the age-old var keyword in JavaScript. Let, as opposed to the var keyword, produces block scoped variables. Here's an example that will help us understand how the block scope differs from the traditional function scope that var produces. So here we have a function called checkNum which accepts a number through a variable called x, and if the number is greater than 10, it uses the var keyword to declare a variable called isGreater which is set to the value true. This variable is then console logged out. When we run this function with the value 20, it prints out true because 20 is greater than 10, and this means that the if block will result in the isGreater variable being declared and set to true. But when we run this function with 5 as the input, it prints out undefined. So what is happening is that the moment this function is declared, a variable called isGreater is created and hoisted to the top of the function with a value of undefined. This is called as function scope, where variables within a function are instantiated or hoisted with a value of undefined to the top of the immediate function, even if they are not used immediately. When the variable is used, its value is just set from undefined to whatever is desired. But as in this case, the value was not explicitly set and hence it shows up as undefined. Now let's examine let. In this version of the same function, we are using the let keyword to declare the isGreater variable. In this case, no matter what value we pass into this function, JavaScript will always throw a reference error which says isGreater is not defined. This is because the let keyword will declare a variable called isGreater only within the block of the if statement, and that can only happen if x here is greater than 10. The console.log being on the outside of the if block is thus unable to gain access to the isGreater variable, and hence we see a reference error. Another example is a for loop. When using the var keyword to declare the loop initializer, you can see that the final value of the initializer is available outside of the for loop as well. If a let is used instead, then the initializer variable is not available outside of the loop. Alright, time to get back to our app. Alright, to see if socket.io is able to connect to the client, we'll go into our browser and hit refresh. And you can see the text connected on the prompt, which means that socket.io on the server was indeed able to connect to the socket.io in the browser, resulting in a connection event being fired, in response to which we are printing out connected on the console. Like the previous video, there's a lot that we have done in this one as well. So go back, watch this video again, and you can pause and code along. And if you get stuck, ping me up in the forum or message me directly.